Hi, I'm going to talk about the two graph traversal techniques. One, BFS or breadth first search. Two, DFS or depth first search. So here's the graph. We are going to find the BFS from source vertex 0. For this, we'll use a visited array. So 5 elements, so from 0 to 4, all of values are 0. We will use a queue, and result will show the resultant traversal, BFS traversal. Since we are at source vertex 0, we add that to the queue, and we start the iteration by seeing if the queue is empty or not. No, we have one element in the queue, so we remove it from the top of the queue, and visited of 0 becomes 1, and resulted value is 0. Now we add the neighbors of 0, that is 1, to the queue, and then there's no more neighbors, so we check the queue. In the queue we only have one value, 1, so we change that to 1, and the visited of 1, it changes from 0 to 1, and result is now 1. We add the neighbors of 1, that is 2 and 4. Okay, now we see if the queue is empty or not. No, the queue is not empty. The top of the queue is 2, so we change the visited of 2 and make it to true, and the resultant traversal is 2, and we remove this from the queue. We add the neighbor of 2, that is 3, to the queue. Now the top of the queue is 4. We change the visited of 4 to true, and the resultant value is again 4. 4 has no more neighbors, so it's popped and no more neighbors are added. Next, we see if the queue is empty or not. No, there's one value, 3, so we change the visited of 3 to true, and the resultant value is 3. We remove it from the queue. Now there are no more elements, so this is our resultant traversal: 0, 1, 2, 4, 3. Now let us see the depth first search traversal from source vertex 0. The visited array is set in the same format as for the BFS, all of the values are 0. Here, compared to BFS, we're using a stack, and then I'm having the result to show the resultant DFS traversal. Now we are at 0, so we add the value to the top of the stack. There are no more elements at the top of the stack to be added. Now we see if the stack is empty or not. No, there is an element. Pop it, we are at 0. Change the value of visited of 0 to 1, and add resultant 0. Now we are going to add the neighbors of 0 to the stack, so 1. Now we are going to see if the stack is empty or not. Yes, it's not empty. We change the visited to 1 and add the result 1 to the end. Next, we are going to pop from the stack, because the stack is not empty, and add its neighbors 2 and 4. We see if the stack is empty or not. No, the stack is not empty, so we pulled out the top of the element 4. We change the visited to 1, and we add it to the result. We then put in the neighbors of 4, that is 3, which is not visited. Next, we see the top of the stack, which is 3. Pop it, and I change the visited from 0 to 1, and I add that to the result. There are no more neighbors of 3 to add, all of them are visited. The stack is not empty, so I pop the top of the element, change the visited to 1, and add it to the stack. So resultant DFS traversal is 0, 1, 4, 3, 2. Thank you.